Hello, welcome to Astronautics for Exploit. This is Dr. Anyashola Ogundele. Deep Space Futuristic Exploration Technologies to propel humans from Earthbound Terrestrials to Spacefaring Explorers. The focus points are deep space exploration and deep space futuristic technologies. Mars, a great destination for scientific discovery and a planet with potential of life existence in the solar system, has captured human's imagination and exploration since many centuries ago. The desire to explore the rare planet spurs from the curiosity to know about the Earth's past, the incoming Earth's future, and to provide answers to humans' eagerness to know and understand whether life exists beyond the Earth planet. Various government space agencies, private space companies, and investors are investing immensely on the development of deep space futuristic exploration technologies that will help to propel humans from being earthbound terrestrials to spacefaring explorers. Some of the future technologies under development to enable humans to explore the moon, Mars, and beyond, and astronauts to return safely to the Earth after a trip to the deep space are crew vehicles technology, deep space rocket technology, deep space probe technology, spaceport, deep space atomic clock, deep space telescopes, advanced laser communication system, orbitals, rovers, landers and flybys, and In-Situ Resource Utilization Technology. Presently, governments and commercial space companies are intensifying efforts to design and develop crew vehicles of the future that will be highly reliable. This is because distant space crew will not have the benefit of frequent resupply shipments to bring spare parts from the Earth like those on the space station. In the area of future deep space rocket technology, Blue Origin, Lockheed Martin, and General Atomics are developing nuclear fusion thermal rockets for use in lunar orbit. The new technology is poised to usher in a new era of spaceflight. Also, SpaceX is conducting test flights of Starship launcher prototype in preparation for the mission to the moon, Mars, and beyond. Deep space exploration. Different government space agencies and private space companies are investing in the development of various deep space futuristic technologies. Deep space is the vast unexplored region of space that extends beyond our moon to Mars and across our solar system. Exploring deep space requires the capability to transport cargo and crew beyond low Earth orbit or farther than 2,000 kilometers beyond Earth. An artist's rendering of a four-quadrant solar cell propulsion system is shown in this picture. These space missions are the future of space exploration, and various scientific and technological advancements being undertaken presently will help to achieve this. The must-have space technologies include a deep space atomic clock, spaceport, a large solar cell, a more advanced laser communication system to improve communication, navigation, and advanced propulsion technologies in future missions. An artist's rendering of the James Webb Space Telescope is shown in this picture. Deep space futuristic technologies. There are different deep space futuristic technologies, and examples are crew vehicles technology, deep space rocket technology, deep space probe technology, spaceport, deep space atomic clock, deep space telescopes, advanced laser communication system, orbiters, rovers, landers and flybys, In-Situ Resource Utilization Technology. Crew vehicles. As humans travel farther from Earth for longer missions, the systems that keep humans alive must be highly reliable and have minimum mass and volume. Both government, space agencies, and commercial space companies are intensifying efforts so as to design and develop crew vehicles of the future, which will be highly reliable. This is because distant space crew will not have the benefit of frequent resupply shipments to bring spare parts from Earth. Crew Dragon Endeavour, which docked with the International Space Station, is shown in this picture. NASA's Orion is the crew vehicle of the future, which is planned to be equipped with advanced environmental control and life support systems designed for the demands of a deep space mission. A high-tech system already being tested aboard the space station will remove carbon dioxide and humidity from inside Orion. Removal of carbon dioxide and humidity is very important in order to ensure air remains safe for the crew breathing, and water condensation of the vehicle hardware is controlled in order to prevent water intrusion into sensitive equipment or corrosion on the primary pressure structure. Orion capsule spacecraft is shown in this picture. This space rocket technology is another deep space futuristic technologies being developed. Presently, efforts are geared towards developing this space rocket technology of the future. As NASA is preparing for a return to the moon with the Artemis mission, NASA is investing in the design and development of a new type of rocket supersonic rocket engine called a rotating detonation rocket engine, which will help with deep space missions. The picture here shows ion thrusters of NASA's Deep Space One. Blue Origin, Lockheed Martin, and General Atomics are developing nuclear fission thermal rockets for use in lunar orbit. The new technology is supposed to usher in a new era of spaceflight. SpaceX is conducting test flights of Starship launcher prototype. This vehicle uses a full flow-stage combustion engine, the Raptor, which burns methane for fuel and oxygen for oxidizer. None of such designs are flown in space. The engines are much more fuel efficient and can generate a much higher thrust-to-weight ratio than traditional designs. The picture here shows illustration of Starship spacecraft. While propulsion usually requires propellant of some description, solar cell is a greener method which relies only on light from the sun itself. Cells rely on the physical property of conservation of momentum. Solar cells have been tested by the Japanese spacecraft, which successfully flew by Venus, and the Planetary Society Light Cell 2, which is presently in orbit around the Earth. An example of solar cell is shown in this picture. Another deep space probe technology is being developed. The space probe is an unpiloted unmanned device sent to explore space and gather scientific information. A space probe is launched from Earth with a set of scientific instruments and tools used to study the atmosphere and composition of space and other planets, moons, or celestial bodies. In order to design this space probe technology, engineers are creating many prototypes, improving the design with each one through iteration processes. The picture here shows various space probes, such as the Parker Space Probe, Ulysses, Geotel, SDO, or SCA. Spaceport is another deep space futuristic technology. A spaceport or cosmodrome is a site for launching or receiving spacecraft, by analogy to a seaport for ships or an airport for aircraft. They are capable of launching spacecraft into orbit around Earth or on interplanetary trajectories. Spaceport technology are being developed so as to include more than one launch complex, which can be rocket launch sites adapted for different types of launch vehicles. The picture here shows an architect's design of futuristic spaceport. Deep space atomic clock is another deep space futuristic technology. Atomic clocks, like those used in GPS satellites, are used to measure the distance between objects. By timing how long it takes a signal to travel from point A to point B for space exploration, atomic clocks must be extremely precise An error of even 1 second can mean the difference between landing on Mars or missing it by hundreds of thousands of miles. Up to 50 times more stable than the atomic clocks on GPS satellites, the micro-ion deep space atomic clock technologies for the future have been developed. Artist illustration of NASA's deep space atomic clock is shown in this picture. Space telescope is another example of future technology for deep space exploration. A space telescope or space observatory is a telescope in outer space used to observe astronomical objects. The first operational telescopes were the Orbiting Astronomical Observatory, which was launched in 1968, and the Orion 1 ultraviolet telescope aboard Space Station Soyuz 1 in 1971. On 16 January 2023, NASA announced preliminary consideration of several future space telescope programs and technologies, including Great Observatory Technology Maturation Program, Habitable Worlds Observatory, and New Great Observatories. The picture here shows Hubble Space Technology, one of the great observatories. Advanced Laser Communication System is another deep space futuristic technology. A laser communication system is a wireless network through the atmosphere which carries the information in the light domain rather than the electrical domain in RF communication. Laser communications is promising for defense and space applications. NASA Laser Communication Relay Demonstration was launched in 2021 so as to test a two-way laser relay system future technologies to link orbiting satellites. Add to Mars laser communication system is shown in this picture. Orbital's Rovers, landers, and Flybys. The flyby is a spacecraft which doesn't go into orbit and only gets one pass. It does this without getting captured by the gravity of an object and entering its gravitational orbit. There's an ongoing effort to develop future flyby technologies. Voyager 1 and 2. Flybys pass by planets or other bodies in space and are equipped with additional instrumentation so as to gain information. Once a flyby passes its target, there's no return. Flybys have only one opportunity to gather the information scientists want. For example, the Voyager 1 and 2. The picture here shows Voyager 2, the first Uranus flyby. A lander is a spacecraft that descends towards then comes to rest on the surface of an astronomical body other than the Earth, in contrast to an impact probe, which makes a hard landing that damages or destroys the probe upon reaching the surface. A lander makes a soft landing, after which the probe remains functional. Examples are Viking 1 and 2 and Tongwen 1. Various landers and lander advanced technologies are being planned for future deep space exploration. Apollo 16 extended Apollo lunar module, a lunar lander, is shown in this picture. Space rover, a planetary rover, is a planetary surface exploration device designed to move over the rough surface of a planet or other planetary mass celestial bodies. Some rovers have been designed as land vehicles so as to transport members of a human spacecraft crew. Others have been partially or fully autonomous robots. Examples are Sojourner, Mirror, and Curiosity. Rovers' future technologies have been developed so as to effectively land on another planet through a lander-style spacecraft and collect information about the terrain. Mars Exploration Rover is shown in this picture. Orbital is another deep space future technology being developed. An orbital is a probe that is sent to a body and continually orbits it for the duration of its mission life. Example is the Space Shuttle Orbital, a spaceplane component of the Space Shuttle, a partially reusable orbital spacecraft system. As sending humans to the moon, Mars, and beyond intensify efforts are being targeted at developing future orbital deep space technologies. Space Shuttle Discovery approaching the International Space Station for docking is shown in this picture. In-Situ Resource Utilization Technology. In-Situ Resource Utilization Technology is the harnessing of local natural resources at mission destinations, such as the Moon and Mars, instead of taking all needed supplies from the Earth to enhance the capabilities of human exploration. NASA conducted ISRU analog missions in collaboration with partners including the Pacific International Space Center for Exploration Systems and the Canadian Space Agency. Together, they validate ISRU hardware which characterizes and extracts compounds like water and carbon dioxide from the volcanic remains. Use of in-situ resource utilization technology and materials to build Mars colony and other equipment is illustrated in this picture. The Mars Oxygen In-Situ Resource Utilization Experiment is helping NASA to prepare for human exploration of Mars by demonstrating the technology to produce oxygen from the Martian atmosphere for burning fuel and breathing. The first human crew to go to Mars will need a lot of oxygen to breathe, as much as 2 to 3 tons. Our body uses that oxygen to burn our fuel called food in order to make the energy that keeps us going all day. This necessitated the need for MOSI experiment. Illustration of MOSI about NASA's Perseverance rover, which created oxygen on Mars, is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to this space futuristic exploration technologies to propel humans from Earthbound Terrestrials to Spacefaring Explorers, presented by Dr. Anyashola Ogundele, with the focus points deep space exploration and deep space futuristic technologies. Thank you.